All right, so in this drawing, I'm going to draw for you the life cycle of a member of the genus Pinus. And Pinus is the genus of pine trees. Pine trees are in the phylum, some people call it Coniferophyta, which would be more appropriate. But we're going to call it the Coniferophyta. These are the cone-bearing trees. Pretty much all of these are going to be trees. Not too many herbs. Maybe sometimes they get a little bit shrubby, but they all kind of have wood in them, which is something we haven't seen. We haven't really talked about wood and how that forms just yet. But the Coniferophyta is one of our 4 phyla of the gymnosperms. And these are going to be seed plants. The seed plants all together do form a clade. The 4 gymnosperm phyla diverged from the angiosperms, but together, because we have this apomorphy of having seeds, which I've previously drawn for you, once again, we're seeing a synapomorphy is defining a clade. Because seedlessness was the plesiomorphic condition, seedless plants are a grade, they're paraphyletic, but seed plants are a clade. They are monophyletic. Okay, so what we're going to do, first things first, let's draw a pine tree, and you can just draw a cheesy kind of stick with a stack of triangles on it. If you want, you can give it some roots, because why not? Of course they have roots. They've got roots, they've got stems, they've got leaves. The needles of a pine tree are the leaves. And rather than just write down this is a pine tree, we're going to give it a sciencey name. We're going to call it a mature sporophyte. Right? Because this is going to be a sporophyte dominant type of plant, because it's vascular. All vascular plants are sporophyte dominant. Okay, and pretty much everything you think of when you see a pine tree, with an exception, is going to be sporophyte tissue. Okay, so on your pine tree, somewhere draw kind of like a oval or a circle up top with some cross-hatching, and then we're going to draw some like cluster of sausages again somewhere else on our tree, because our pine sporophytes and many members of the Coniferophyta, I think all of them, maybe all of them, enough of them, have 2 different types of spores produced on the same plant. Okay, so when we have seed plants, all seed plants are heterosporous. That's a prerequisite for being able to produce seeds, is having 2 different types of spores. But within the Coniferophyta, these are all producing both types of spores on the same plant, and we call that monoecious, which means one house. Mono means one, ecious is like economics, ecology, and it always means house, something to do with the household. All right, so we've got both types of spores being produced on one sporophyte. So we're going to start with our so we're going to take our hot dogs and we're going to draw some lines going one way, and then we're going to draw some lines going the other way. What these hot dogs are the micro sporangiate strobili. Okay, so these are going to produce the microspores, the little spores, or we can call these pollen cones. Same deal. Okay, and a strobilus is a cluster of sporophylls, and sporophylls are a type of modified leaf that produces spores. Okay, so a microsporangiate strobilus is a cluster of microsporophylls. So if we were to take one of these pollen cones and kind of zoom in, and they do kind of, if you look at them up close, you do see they have this kind of spiral arrangement of the sporophylls. So let's pull off one sporophyll. What we'd see inside one sporophyll, a microsporophyll, is that it is full of microsporocytes. And CYTE is a word root that means cell. Aren't there cells all over the place? Yes, of course they are. These are multicellular organisms. But in this context, for the plants, when you see this CYTE, you should think, aha, next thing that's going to happen is meiosis. So those microsporocytes are going to undergo meiosis. I'm not going to write undergo, I'm just going to write meiosis. And of course, meiosis means diploid becomes haploid. And now our microsporophyll, if you want to, now has 4 times as many cells in it because it's undergone meiosis, and now it is full of microspores. So remember, we are heterosporous, 2 different types of spores, and we're doing the microspores, we'll do the megaspores next. Okay, so the job of the sporophyte, in one sense, is complete, because its job is to produce spores by meiosis. That's done. Now what? Okay, well, next thing that has to happen is mitosis to produce the gametophytes, the microgametophytes. So I'm going to draw that microsporophyll one more time, and now I'm going to fill it with what looks like Mickey Mouse heads. Because now, if we zoom in on one of those, what we find is this is the microgametophyte. Which is the same thing as a pollen grain. Which is made up of 4 haploid cells. That's all a pollen grain is it's 4 haploid cells, and each pollen grain is what part of the gametophyte generation of the plant. So technically speaking, each pollen grain is itself a plant. A tiny little plant, just 4 cells. Those cells are differentiated, so they don't all have the same job, so it's not a colonial structure, and there's more than one cell, so it's not unicellular either. So it's a multicellular organism. So when the air starts turning yellow in a short period of time here, know that all of those individual little pollen grains, which together make up the the yellowness of the air, each one of those pollen grains is a individual microgametophyte. Okay, so we're going to put that aside for now and go to our megasporangiate strobilus, which is our ovulate cone, or maybe what you normally think of as a pine cone. She's also a cluster of megasporophylls. So if I were to take a cross section through our megasporangiate strobilus, you'd see there's kind of like a central axis in there, and you've got a whole bunch of these scale complexes. Let's see if I can't find a picture to edit in here. It's just, okay. And we're going to take one of those and I'm going to draw it exaggerated for you. All right, so now we've got a mega sporophyll. And inside of that megasporophyll, this right there is the megasporangium. And we've got one little spot in there, which is going to be the megasporocyte. Okay, and if you're any good at recognizing patterns, like what happened down here, what happens to things that end in -cyte? They're going to undergo meiosis. And here we have no exception, so that is going to undergo meiosis. And I'm going to draw pretty much everything all over again, only plus one step. All right, so notice I drew kind of like one bigger circle and three little circles. I'm going to include our little meiosis box, so we know that that's happened there, right? Happened down here, it's going to happen up there. So we get one megaspore, which is haploid, plus 3 cells that don't make it. Remember, meiosis gives us 4 cells. At least it gives us 4 nuclei. And only one of those is going to, because it's going to become the big one, it's going to get all of the cytoplasm from the megasporocyte. So these 3 other nuclei, these polar nuclei, are just going to be reabsorbed. They're not going to make it. Okay, while we're here, I'm going to point out that this little space here, this little gap here, is called the micropyle. And that's where the microgametophytes are going to be able to get in to fertilize the megagametophyte once it forms. Turns out it's real quick and easy to make the microgametophytes. The megagametophyte, it's going to take some time, which is why I drew the microgametophyte first. Okay, so inside that megasporangium still there, we're going to have some mitosis, and I'm I'm going to draw our micropyle. Oh my goodness. Okay. And so now we've got our megasporangium, our container for the megaspore. But the megaspore has already gone and done its thing. And we've got a megagametophyte. Megagametophyte. All right, so we're going to draw all this again a couple more times. I'm going to make it even a little bit bigger down here to draw in some details. All right. Okay. So here's our megagametophyte here. Inside the megagametophyte, we have some archegonia, which contain eggs. Because the job of the megagametophyte is to produce the megagametes, which are the eggs. And that megagametophyte is surrounded by the megasporangium. I'm going to draw this all one more time. Whoa, you can see how great I am at drawing things because all of these things look exactly the same, right? And they're pretty close. Close enough. Okay, so we've got our archegonia there. Gonna take our little Mickey Mouse guy here and gonna add our microgametophytes. And our microgametophytes, our pollen grains, are going to sprout a pollen tube which grows through the megasporangium, through the megagametophyte, into the archegonia to fertilize the egg. So the microgametophyte, there's a cell in there called the spermatogenous cell. That's what it is, which is going to divide by mitosis. One of those 4 cells is going to divide by mitosis to produce 2 sperm, and one of those sperm is going to fertilize the eggs, and the other one is a backup. Okay, so now I'll draw everything kind of back to smaller. And you notice that there's like a bunch of pollen that's getting in there, but only one of those eggs is going to get fertilized and develop into the zygote, which means between here and there, we must have had a restoration of being diploid through fertilization. And then that zygote is going to grow by mitosis. There we go. Okay. That micropyle is going to be fused shut. And I knew it kind of looks like I drew a spork inside of there, but now we have got, through mitosis, we've got our seed coat, we've got our endosperm, which is made from what is left of the megagametophyte and the make a sporangium. And then inside there, we've got our embryo all together. What that means is we've got a seed, our baby in a lunchbox, and that is going to grow into our next mature sporophyte with any good fortune. All right, so that's our complete life cycle of a pine tree. Most of this stuff is, you'd have to look very closely to observe it all. The vast majority of the life of this thing, 99.99%, is going to be being a mature sporophyte. But this is how we get the next generation. We alternate the generations between diploid, haploid, and then diploid again.